Assalamualaikum warahmatullahi wabarakatuh. Okay, good afternoon, everybody. My name is DINAYAH and I will be conducting my presentation in English. Welcome to the pre-undergraduate thesis defense of mine, study program of Agricultural Engineering, Department of Agricultural Technology, Faculty of Agriculture, 2025. Alright, next, the title of my research would be Estimation Model of Carbon Storage in Robusta Coffee Plants. The Honorable Advisor Lecturer Dr. Rizky Tirta Adi Buddha STP MSc and the Honorable Examiner Lecturer Professor Dr. Insinyur Daniel Saputra MS Associate Engineer, and today is the 8th of May 2025. And I will begin by my research background. I have 3 points here. The first one is climate change. We all know that it's a very serious matter to be tackled on. We couldn't seem to close our eyes. There's a lot of negative impacts both to the humankind and the environment. Okay, and that comes to my second point, which is the global mitigation. In any part of the world, we already come up with solutions and mitigations, including the SDGs, the point 1 until 17, which is to improve the people's welfare, and then the United Nations back in 2015 with the Paris Agreement, they made the 1.5 degrees Celsius threshold, which is a limitations on which where the temperature of the world must stay well below the 2 degrees Celsius in order for the Earth to stay quote-unquote safe, right? And then the third one, the amount of coffee crop yields in South Sumatra is many. Nationally, we are determined to be the top producers or contributors of coffee crop yields in Indonesia. So that's why I think it's very crucial for me to include the point number 3. Okay, moving on. And then the research objectives. The research aims to develop a model for estimating carbon storage capacity in Robusta coffee plants and analyze its potential as a nature-based solution in decarbonization targets and provide recommendations for the application of the model in sustainable agricultural practices. Okay, next, the implementation of research. The location is in the Biosystem Laboratory, Department of Agricultural Technology, Faculty of Agriculture, and Sriwijaya University, and research period. The research was conducted starting in February 2025 and then continued until completion by the end of April 2025. Right, the tools and materials, it was simple. For the sample preparation, I used diameter, tape, and then chainsaw, and then mesh number 60 sheave. And then for the proximate analysis, it was all provided by the lab. Like a number 1 titrator, and then thermographimetric furnace, and then analytical scale. For the ultimate analysis, we have colorimeter, elemental analyzer, infrared spectrometer, gas chromatograph, mass spectrometer, atomic absorption spectrometer, and then inductively coupled plasma mass spectrometer, or ICP-MS for short. And for the material, I only use one, which is the stem or trunks of Robusta coffee plants at various different diameters. And then for the research methods, I use the completely randomized design, or in Indonesia we like to call it RAL, rancang acak lengkap method. And the tree manufacturer used was the size of the tree trunks and then of the one type of coffee variety, and that is Robusta, right? And then factor A, which is the plant stem diameter size, consists of 4 levels. A1 trunk diameter ranges to 5 to 10 centimeters, A2 10 to 15, A3 15 to 20, A4 20 to 25 centimeters. Right, and then the methods of data analysis, I use 3 different models to determine the variable. Number 1, which is allometric for the linear approach, and then for the non-linear approach, I use 2 models, which is Gompertz and exponential, which each model will be evaluated with the metrics of R-squared, RMSE, and MAPE. I will explain more on that later. Okay, moving on. Okay, this is the workflow of the research. So number 1 will be preparation. The tools and materials will be provided by the laboratory, and then number 2 would be sampling. Before we select or cut the sample, we must measure it first, whether it fits or meets the criteria for the samples or not, right? And then 3 is processing, milling, and sheaving according to the standards, which is the ASTM 13, and then the year 2002. And then number 4 would be analysis, proximate and ultimate. 5, validation using those 3 models that I just mentioned. and then evaluation using also the three evaluation error metrics that I just mentioned, right? And then the model validation, this is the linear approach. This y equals ax to the power of b would be the general form of the formula for the allometric model, and then we would derive from there to logarithmic equation, and then we would regress with the linear by OLS, and then yeah, we look for the parametric compression and then integrate the parameters to the equation. I'll show you in a bit how to do that in using Excel software, right? And then these for the nonlinear approach, we have Gompertz model and also exponential model. Y would be the diameter, Y would be the carbon that we're trying to seek, right? And then A, B, and C should be the variables, and then E should be the Ural numbers, and X is the diameter. Same goes with the exponential model, right? And then the model accuracy evaluation. After I got the data from integrating the raw data to the models, I'll evaluate whether or not the models is accurate enough to be used to estimating the carbon storage capacity itself. Right, so this is the results. I'll start from proximate analysis. Number one would be the total moisture. As you can see, sample A3 has the highest moisture, and A1 has the lowest, with 21.43% AR. AR should be as received basis. And then table 2, the ash content. Sample A2 showed the highest, and A4 had the lowest, which is 1.37% AR. Right, and then table 3 is volatile matter. Sample A1 has the highest, A3 has the lowest with 60.97% AR. Fixed carbon, which is totally supports the hypothesis, which A4 has the highest fixed carbon, 13.46% AR, and A1 has the lowest with 12.76% AR. Okay, I'll move on with the ultimate analysis. I'll start with the sulfur, which is very clear that sulfur's content is very low in accordance with the sulfur line characteristic of the plant's stem biomass. And then for the carbon, samples A1 and A4 have the highest carbon content with 38.16 and 38.13% AR. And then the hydrogen, high hydrogen in A1 is related to moisture content, while volatile hydrocarbon compounds, and the low hydrogen in A2 was due to oxidation during storage. And then for the nitrogen, the high nitrogen in A1 comes from the dominant plant stem biomass, and the low nitrogen in A2 indicates the lack of dominance of woody biomass. Right, this should be the performance evaluation of the estimation model. The x-axis should be the total carbon against the x-axis, and then the y-axis should be the total carbon, and this should be the diameter. Right. As you can see from the line, Gompertz should really fit into the models in terms of accuracy, and I'll explain to you why. All right. Okay, there you go. This is how I integrate the raw data into the each of the models, right? And then here you go. Here's the model for here's the equation or formula for each of the equation, and then here's the model accuracy comparison, where we can see the R square for the Gompertz is the highest, and for the RMSE, allometric has the highest number, and for MAPE, allometric and Gompertz are pretty much equal. And then the conclusions, the Gompertz model, R square equals 0.988 proved to most accurately predict the carbon storage capacity in robusta coffee plants based on stem diameter, or DBH, which with the use of actual carbon constants, replacing the assumptions of the Indonesian national standards, right? And then the second one, robusta coffee plant has potential as a nature-based solutions through carbon storage and sustainable agroforestry systems that should support climate change and mitigation and adaptation. And 3, application of the Gompertz model is recommended in sustainable agricultural programs such as carbon certifications and REDD+, through farmer training and for DBH monitoring and policy advocacy based on actual carbon values. And recommendations, further research needs to expand the sample coverage to different coffee varieties, geographical locations, and agroecological conditions, and integrate environmental variables and cultivation practices into the model to improve prediction precision. And also, collaboration with policymakers is needed to test the model's application in carbon trading schemes and community-based climate resilience programs. Right, so appendixes, here you go. I used the hypothesis for the curve using Google Colab and Python programming language, but it turns out it did not go as well as the hypothesis, right? And then the selection and sampling, and then the sample preparation, we have mailing, sieving, and vacuum sealed the samples, right? And here you go. I process the raw data and integrating it into the model using the Excel software, and then for the final curve I use the Curve Expert Pro software. Right, and here's the workflow. As I explained before, it's completely the same. And thank you so much for listening. I think that's the end of my presentation for the pre-undergraduate thesis defense. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.